Hello everyone. We will discuss today about the Miller indices and particularly talk about the directions. Okay. So here I have marked 2 points A and B. Suppose someone asks you to go from A to B, right? So you will understand that I have to reach B and I have to start from A. So you will go in the direction of B, right? So how you will find the direction? So you'll just try to make a straight line, right? You will try to look at the position B, and from there you can say that okay, I have to reach that direction, so I will go in a straight line. Okay, so the reaching over there can be in different paths also, but this will not be the direction, right? Okay, so the shortest path it will be, that will be called as direction, right? Okay, so similarly, like suppose someone asks you to go from this Dehradun to this Tamil Nadu, okay, so you can make a straight line that will give you the direction from west to east, from Gujarat to Assam, okay, so like this. Okay, so now for the Miller indices of direction, so basically it is a kind of vector, okay, and that is represented in terms of r equal to r1a plus r2b plus r3c, where a, b, c are basic vectors and Miller indices are r1, r2, r3. Basic vectors means the three directions like the a, b, c, right? And r1, r2, r3 are some numbers, okay. So if R1, R2, R3 are in any kind of fraction, then we try to remove this fraction. Okay, so how do we remove the fraction? So by multiplying the largest denominator, which is over there, and so that the other fraction which is also over there, so that also becomes integer. Okay, so maybe we will have to multiply by the LCM of this two denominators if 2 are there, or if maybe the 3 are there. Okay, so if for example 1 3 by 4 1 by 2 multiplied by 4, then it will give this. Okay, now see here, this is one example of direction it is shown. Okay, so now suppose this is your A vector. Okay, so this is your A vector and this is your B vector, and you have been given this direction and you have to reach this point, right? So to reach this point, so how can we write this vector? So this we can assume like r vector. So we have the A vector, right? So A vector, so we can understand how will you reach over there. So we'll have to go this 4 times, right? 4 times of A. This is your 1 unit of A, right? So you will go 4 times of A, then you will go minus 2 times of B because it is in the negative direction. Okay, so B it is given over here, it is in negative direction, this is a positive direction. Okay, so positive and this is negative, so minus 2B we can write like this. So this becomes the Miller indices become 4 minus 2, right? So that you can write as 4 2 bar. Okay, so negative we do not keep while writing the Miller indices, so we convert it into the bar. Okay, so we have drawn this line. So so this basically Miller indices also indicates the lines which are parallel to each other. Okay, with the parallel lines will have the same Miller indices. Okay, like the blue lines it is given over here. Okay, so there is one more method to basically know the Miller indices for the direction. Okay, so in the previous method it was assumed that the direction which we are measuring is originating from the origin. Okay, and that is the simplest one we can think of. Like there in that case, here it will be x, y and z. I have taken these x's, you can take yours, but if it is given in the question, then whatever direction it will be given, that you need to take. Okay, suppose this direction it is marked, right? So you have to go from this origin to this point, right? So what will be the method to go? So from origin you have the three axes x, y and z, so you will have to travel along these axes only, right? So to reach over there, so you need to travel one distance by x, then one distance by y, so it will be nothing, the coordinate of this will be 1 1, and you don't need to move in the z direction, so 1 1 0, right? So this r vector you can directly write 1 times of your x plus 1 times of y plus 0 times of z, right? So this will be like x vector and y vector. So this r vector is nothing but 1x bar plus 1y bar. So Miller indices will be nothing but 1 1 0, right? Oh, 0 also we need to keep, okay? Do not ignore this. Okay, so this is one way, and there is another way. You must have seen this formula. So it just tells you that suppose any axis is given and if line is already marked, okay, so in that case how can you find the Miller indices for a direction? So you just need to, you know, do these things. You just hide the denominator right now. Okay, now suppose you hide this denominator like a and b and c, you forget this. So x2 minus x1, so you will start from this point x1 y1 and z1, and second point will be x2 y2 and z2, right? So like the example I told you about a and b, right? So you will start from this point to that point, so you will just subtract the coordinate, so x2 minus x1, y2 minus y1 and z2 minus z1, okay? And this subtraction will be in terms of some fraction of the length of the axis, right? So we have assumed the a, like a unit of in the x direction, b unit in the y direction, c unit in the z direction. So that's why we will divide it by a, then b, then c, right? So this is the most useful formula, okay? See guys, so when we use the cubic one, okay, so basically this a b c all these, that is equal to 1, right? So we can ignore this one also, but okay, let it be over here right now to understand. So now suppose this is the green line which is drawn over here, and axis is already given x, y and z. So we'll have to mark this point, right? A point, then b point. So where the arrow ends at the b, right? So a point, what is the coordinate? So it will be 1, then 0, then 0, right? B coordinate, it will be like x you do not need to go, y you will go by 1, and z you will go by half, right? So we have to do nothing but b minus a. So it will be nothing but 0 minus 1 in the first case, then 1 minus 0, then half minus 0, right? And divided by this unit a, right? So in the x we have assumed a. So this coordinate is nothing but, I have written here like 1 0 0, so it will be exactly equal to like a 0 times b 0 times c, right? Something like that. It will be a times 1, then it will be like 0 times a, then 1 times b, then half times c, right? So it will be nothing but 0 minus 1 a, right? Because 0 a multiplies a, it will be common, right? So it will be like b, then c, then c, right? So these gets cancelled, then c c c, so it becomes minus 1 1, then half. So you are getting here the denominator 2, so we need to rationalize it. It's in the terms of integer, so you will get minus 2, then 2, then 1. So minus 2 2 1, you can write it as 2 bar 2 1, okay? So you got the answer. Very simple, right? Yeah, so it goes like this, okay? So here in this you will have no problem, means wherever be the origin, so there you can mark the Miller indices of this. Okay, this is the formula. Simply, if you want to remember the trick, then simply you have to do subtraction from your head to tail, right? So this is your head, this is your tail. So head coordinate, what is the point of coordinate of that point minus the tail coordinate, right? And you will get from there the value of that. So this is the Miller indices in the case of normally the cubic one. So we'll discuss the hexagonal in the next class. Okay, so thank you.